Okay, here we go. Pre-calculus, chapter 12, section 4, homework page 851. We're going to talk about, in this section, limits at infinity. Okay, we're going to take limits at infinity and limits of sequences. So we're going to evaluate limits of functions at infinity. Okay, we're going to try and think about and evaluate when n goes to infinity or x goes to infinity and limits of sequences. Okay, so if f of x equals a fraction, okay, a rational function where I have a numerator and a denominator of x's. So when a function is a rational function, there's a function on top and function on bottom, okay, rational, then limit as x goes to infinity, okay, we want to take the limit of this function as x goes to infinity. This will be 0 if the denominator has a bigger power than the numerator. This will be the fraction of a over b, the leading coefficients, if the degree of the numerator and denominator are equal. And then there's no limit if the degree of the denominator is less than the numerator. So we're going to explore basically the degrees of the numerator and denominator. Okay, we're going to compare them. When the denominator is bigger than numerator, okay, denominator is bigger than numerator, limit is going to be 0. When they are the same, then we look at the coefficients, and then there's no limit when the denominator is less than numerator. Okay, so let's do some examples. All right. So we're going to take limits as x goes to infinity. So for example, the idea is pretty simple, but might be a little confusing if this is if you don't think about it, right? Limit as x goes to infinity, we're going to think about infinity of 7 minus 1 over x squared. Okay, so what happens as x goes to infinity? So you see the limit of 7 as x goes to infinity, 7 doesn't get affected at all. But when x goes to infinity, got to think about this, all right? When x goes to infinity, you're going to have 7 minus 1 over infinity squared. Infinity is a really big number. When you square, it's going to be huge. So 1 over a huge number is going to be 0, right? Basically. So this will give you 7 minus 0. So your limit there is 7. Okay. We can also simplify this if you want to play jealous neighbors. Okay. If you want to simplify this problem, it will be 7x squared minus 1 over x squared. So now you notice, look at the power on top. The numerator has a degree of 2. The denominator has a degree of 2. And since the powers are the same, since the degrees are the same, we look at the coefficients. The coefficients is 7 and the bottom is 1. So that's why your limit is 7. Okay, so when you have a rational function, okay, you compare the degrees. Okay, limit as x goes to infinity, okay, of negative x plus 4 over 5x squared plus 2. Okay, so here's another limit as x goes to infinity. This idea is pretty simple. Okay, check this out. What's the degree of the numerator? What's the degree up here? Degree is 1. Okay, degree of the denominator. The degree of the denominator is 2. Okay, so in this case, okay, the denominator is bigger than numerator. So my limit as x goes to infinity equals 0. When the denominator degree is bigger than numerator degree. Okay, if you think about it carefully, okay, you have negative infinity plus 4, which is still negative infinity. On the bottom, 5 infinity squared. Okay, which one's gonna dominate? Okay, which one's gonna be, if you think about like this, they will also cancel. You get -1 over 5 infinity, right? These will cancel. So 5 infinity is a really big number. 1 over that, basically that's why you get 0. Okay. Okay, let's do some more examples. Let's say limit as x goes to infinity of negative x squared plus 4. And we have 5x squared plus 2 again. Okay, degree of the numerator is 2. Degree of denominator has a degree of 2 also. So since they're equal, see how numerator and denominator equal? Since they're equal, we want to look at the coefficients. Use their coefficients to compare since they are the same. Since the degrees are the same, we look at the next best thing, the numbers in front of them. So my limit will be -1 and 5. So that's my limit. Okay. So last example here. Let's say limit as x goes to infinity of x cubed plus 8. On the bottom, 5x squared plus 7. Doesn't matter. Okay. So numerator, what's the degree up there? Degree is 3. On the bottom, what's the degree on the denominator? 2, right? So in this case, okay, my denominator is less than numerator. When that occurs, no limit. That's it. Simple. Okay, so we're just comparing powers. That's how you find limit as x goes to infinity. All right, try some on your own.